PreCalc. We found how to graph some inverse trig functions, and now we're going to use them algebraically. So let's come to understand how that works. Just as a review, when I talk about inverse trig, so inverse trig again, we're taking functions like sine and cosine and looking at arc cosine, square root of 3 over 2, for example, and cosine, sometimes we call it cosine inverse. Those are the same ones. So arc cosine and cosine to the -1, read inverse cosine, are the same operations, just different ways of saying the same thing. So let's figure this out. As you recall, when we take the cosine of an angle, that's what we're used to doing, we would get a number. So I think the cosine of an angle like pi over 3 was 1/2. So now we're doing it the opposite way. We're saying cosine inverse, or arc cosine of 1/2 equals pi over 3. So now we're taking the arc cosine of a number and coming up with, an angle. So we're working backwards. Before we looked at the cosine of the angle and got a number, and when we say arc cosine of a number, we want to know what angle has this as its cosine. The arc cosine of a number is an angle. So pulling that back to our problem here, this is saying what angle has a cosine of square root of 3 over 2. Now we learned we can only look in quadrants 1 and 2 for the arc cosine. So in my mind, I'm thinking of the unit circle, and I'm only looking in 1 and 2. So in there, where can I find a point along the unit circle where the first coordinate is square root of 3 over 2? So I might check this point down here. To get here, I went over the long and up the short. So its coordinate is square root of 3 over 2, 1/2. The first coordinate is the cosine. So I found it. What angle is that? It's the very first one, pi over 6. Alright, so if you looked at your unit circle, I just built the part of it that I needed to answer the question. Alright, where would I find a cosine inverse of -1? Well, I remember numbers like that appear here, here, and here. And originally I called that the monkey math because I thought you could teach a monkey to do these points. But actually they were more problematic than I thought, so kind of sorry I called it that. Alright, so this point is 1, 0, this point is 0, 1, and this point is -1, 0. So which one has the first coordinate, a cosine of -1? There it be. So what angle is that? That's pi radians. Alright, so that's our thinking for, we established that earlier. And let me remind you, remember I just told you that arc cosine was restricted between the first and second quadrants. We write that like this, between 0 and pi. That's the first and second. Arc sine, we are restricted for looking at our answers between -90 or negative pi over 2 and positive pi over 2. That's the first and the fourth quadrants. And arc tan is just like sine. So same restrictions, first and fourth. Alright, so that's a review. So now what we're going to build on that is we're going to use these inverse trig properties to do some problems now. And we've looked at their graphs and we're happy with those. So now we're going to do problems that look like this. Tangent of arc cosine of 2 over 3. So this is saying, first of all, to do this. We're trained to do this. We're asked to find an angle that has this as its cosine. Now wait a minute. There's nothing on the unit circle that has a first coordinate of 2/3. So we're going to come away from the unit circle and look at other situations as well. So I can't find it on the unit circle, but I can draw it. So I know our cosine is going to be within the first or the second quadrant. But I know cosines are all negative on the second quadrant, and since 2/3 is positive, I'm going to draw an angle and make it into a right triangle, and I'm going to give it these measurements. So this is adjacent, this is hypotenuse. So adjacent is 2, hypotenuse is 3. So before I finish, I won't even go any further. I'll go ahead and find this unknown side. I'll call S. So the Pythagorean theorem, 2 squared plus side squared equals hypotenuse squared. And solving that for S, I get 4 plus S squared equals 9, or S squared equals, subtracting 4 from both sides, I get a 5. And the square root of S squared, square rooting both sides, I get 5. I really get plus or minus square root of 5, but I know this distance S cannot be a negative value, so I'm going to pick the positive one. Alright, so now I'm ready to go on. I always do that if there's a missing side. Alright, so now this is asking me for the tangent of this angle. And this is the angle that has this as its cosine. So even though I don't know what this angle is, I've drawn a picture of it. So now I want a tangent of that angle. And that I can do without even knowing what the angle actually is. And that, because tangent is an opposite over adjacent. So I'm going to pick opposite. Opposite over adjacent. Square root of 5 over 2. So that's my final answer right there. So do you see how I went inside and found the angle that had this as its cosine and took the tangent of it? So just follow your mathematical nose and it will lead you where you have to go. I'll do 2 more. Cosine of the arc sine of negative 3 over 5. Alright, so I check and see, I think, is this on the unit circle? Is there an angle that has this as its arc sine? Alright, I haven't seen it. It's not the long guy or the short guy or the medium guy, so we're going to draw this one. So I notice this one's negative, and I can look for arc sine in the first and the fourth quadrants. So the positive ones are up here, so I'm going to draw this one in the fourth quadrant. Alright, so notice the hypotenuse comes out from the origin, and then I connect to the x-axis to finish the angle, the right triangle. So the angle I'm talking about is this one, and it has an opposite over hypotenuse. So I'm going to assign opposite this angle -3 and hypotenuse 5. So before I go any further, I'm going to find the unknown side, S. So Pythagorean allows me to do that. So I get 25 minus 9, which is 25 minus 9. 25 minus 9. Come on, brain, catch up to what you're doing here. 16. I'm so sorry. All right. I was thinking it came out to, on my paper earlier to another number, but this is a fine number. All right. Sorry, I had that momentary senior moment. So S equals 4, which is sweet. All right. So I have 3, 4, and 5. All right. So now I come back here. And I don't know what the angle is, but I've drawn a picture of it. So I want the cosine of this angle. And that is adjacent over hypotenuse. And I'm going to get 4 over 5. So the final answer is 4 over 5 for that problem. All right, sometimes we get fancy pants. And we do one like this. All right, we do sine of the arc cosine of 3x. All right, so how's that different than these two? Well, right here I have a 2/3, here I have a negative 3/5, and here I have a 3x. So I have an unknown in my arc cosine, but I can handle that. So I notice cosine, so I'm looking for the angle whose cosine is 3x. Well, it turns out that that's a positive value, so I'm expecting cosine in the first or the second, but the first, they're all going to be positive. So 3x is positive, so I'm going to draw my angle in the first quadrant, and I'm going to make this a fraction, 3x over 1, and this is side adjacent, this is side hypotenuse. So I'm going to sine those to this angle. Here's the adjacent, here's the hypotenuse. So now I have to find side S, and I get S squared plus quantity 3x squared equals 1 squared. And squaring 3x, I get 9x squared. And 1 squared is 1. Solving for S, I move the 9x squared over. It subtracts to the other side. And I take the square root of both sides. So, not your common everyday answer, but now we know this side has to be the square root of 1 minus 9x squared. All right. So, now I've finished that. I don't know the name of this angle, but I have drawn a picture of it. So I want to find the sine of this angle. Sine is opposite over hypotenuse. So the answer to this one is opposite of 1 minus 9x squared over 1. You don't have to write the over 1 part. So simply square root of 1 minus 9x squared. All right, so that is your answer. In fact, the calc kids are going to be using that a lot. So if they forget how to do it, you're going to come up and step up to the plate and tell them. All right, that's it for tonight. Our work tomorrow will involve this algebraic expressions involving inverse trig. So, till then, over and out.